Press Command-I to run your app using instruments. This will build your code in release mode, which means it's designed to be fully optimized for maximum performance, which is very different from debug mode, where it's designed to make debugging easy. When this screen appears, that's instruments right here, and you'll see there are lots of different ways we can go ahead and scan our app. I'd like to choose Time Profiler, then press Choose. This new window will appear, and all being well, you have your device selected here, then press the Record button here to start recording of the app. This will launch inside the simulator and start scanning. It's now recording. So I'll go ahead and go to Simulator, and here's the app running. Here's a sharp spike when the app first launched. That's doing all the launch work. We don't care about that for now. We're more interested in the workload of the app once it's running. So I'd like you to scroll around a little bit, like this. Just use the app like a normal user would do. You can see various spikes appearing. Then when you're ready, choose any one of the items. I'll choose RTFM. Read the fine manual. Then go back. I'll do LOL, lol. And then go back again. I'm just using the app, as you might normally do. You want to aim to get a good few seconds of the app running, like that. Then press stop. And here, this shows the results of our scan, exactly what our app was doing the entire time. This top half of instruments up here, this is showing us readings from our app. This bottom half, this is showing details on those readings. By default, the detail view shows everything in the app that was captured. This is a summary of the entire app run that just happened. But I want you to click and drag just a small part. You can see here, this big lump here, that's when I clicked on an image. I'm going to select that part. Let's click and drag over it. Let's say duration, 3.5 seconds or so, and release that. And now our detail here is showing us only the parts of the run from a section we just highlighted. Now you can see from here, the vast majority of time, 99.9% of time, was in the main thread. That means we're not taking any advantage of having multiple CPU cores. Just to the left of main thread, you'll see a disclosure indicator. That's this arrow here. If you click that, you'll see inside, you'll see start. Inside there, there's another arrow, you'll see main. And you can dig more and more and more. If you want to, be careful with this, you can hold down the Option key, then click on an arrow. But that will cause all the children, all the arrows, and their children's children, and their children's children's children, and so forth, to be opened up, which gets messy really quickly. Instead, there are two options. First, this right-hand detail pane, which you may have had hidden, but you can show by pressing this button up here. That detail pane shows us the heaviest stack trace, as you can see right here. That's the code that took most time to run. Now, if I scroll down here, you can see lots and lots of code running, and eventually you'll see this part here is highlighted in white. That's our code, and you can see it saying image view controller view did load. That is taking the most time to run. And the reason it's white is that's our code. The rest of this code, UI, navigation controller, start, defer, transition, so forth. This is all being done by Apple's code, by system code, not our code. All this other stuff down here, all being done by Apple, not by us. This part, the view did load, that's our code in our actual Swift code. So that's why it's highlighted in white. You'll see next to it this number here, 2277. That's telling us how long it took for that piece of code to run. So this whole thing had 2,306 milliseconds, 2.3 seconds. Our view did load method took 2.27 seconds to run. And there is lots of graphics rendering stuff, CG display list drawing context, RIP, layer bit image, RGB A32 image. Basically lots of image drawing stuff down here is taking all the work inside view did load. The second option that might help is called invert call tree. It's down here and there's call tree button. You just choose invert call tree from this menu and it flips the whole layer around. This will show you the heaviest code first up here. This ARGB32 sample, ARGB32 part. That's the heaviest code sample there, taking up 1.52 seconds. When you dig into that in the arrow here, it'll tell you what called it. In this case, it was ARGB32 image mark. So there was RGB image and ripple mark and so forth. You're actually digging in reverse. And eventually you'll come back to the same code after enough digging. Let's go way, 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 way down. There we go. So here's our UI graphics image renderer stuff, doing all the drawing in here. And finally, view did load. So it's the same thing as this, just now reversed. So we have to go the other way around with disclosure indicators. There is a third option, but it's of mixed help. Back in this call tree menu, you'll see an option here called Hide System Libraries. This will eliminate all the time being used by Apple's frameworks, so you can focus on your own code. This is great if you have lots of complicated code that could be slow, but it doesn't help at all if your app is slow because you're using Apple's system libraries poorly. Now press Command Q to quit instruments. Go ahead and choose Don't Save, it's fine. Back in Xcode, I'd like to press Command R. It's a normal run of the application. Now though, rather than using the app, I'd like to go up here to this debug menu and see some interesting options in here. Color blended layers, color copied images, color misaligned images, and color off-screen rendered. These are all useful pieces of information when debugging. Let's try color blended layers now. Select that option, and you'll see our UI becomes a mix of red and green and kind of a browny color here. What you're seeing is it's telling us which views are opaque and which are transparent. Views that are opaque, I have a solid background color. There's one at the back here, this nice white background. That's green here. It's fully opaque. Whereas translucent views are colored red. And where there are multiple transparent views inside each other, like you have up here or down here, you'll see more and more red. Let's turn that off again and try going to off-screen rendered. And now you'll see views that require an extra drawing pass colored yellow. Some special drawing work must be individually done off-screen, then drawn again onto the screen, which means a lot more work. Broadly speaking, you want color blended layers to show as little red as possible, and color off-screen rendered yellow to show as little yellow as possible.